Alright, so changing out the coils in a BMW R100/7. These are the new coils. The coils that were in it were probably not the original ones. In fact, I'm pretty sure they weren't. Um, so I came up with a fairly good solution. The coils that were in it had um, the plug lines were integral to the coil. So I wanted to make it so that I could remove the plug lines. Um, uh, so I purchased these two dual tower coils because it is bottom plugged. It's dual plugged, so it does have a custom bottom plug. And so these were 3 ohm coils. The measurement off of the old coils was 4 ohm, but I'm making it a little bit of a faster, hotter coil because I am putting a 1K resistor cap on the plug line. The plug cap is going to be 1K. So I doubt that the coil that was in it was really matched up very well when the um, ignition changeover from points to electronic ignition occurred. So it looked like, they just slapped the parts together. I doubt they really thought about it too much. So I don't think a hotter coil is going to really be a big problem. The difficulty with assembling these, inserting these into the R100/7 BMW is that fitment. It has to go uh, underneath the frame, which would be right in here. Existing mounts are up here, and it also has to be squeezed in between the fuel tank. So if you go this angle with the towers, it hits the fuel tank. If you go this angle with the towers, it hits the air intake. Consequently, the only real possibility of using this kind of a coil setup is to put them at 45 degrees, um, 90 degrees to each other, 45 to the motorcycle. So what I found is that they have a nice flat spot. You can see on this side, nice flat spot. So it mounts up nicely here, and I had some of this scrap left over, so I started cutting it up. First I used the diamond tip blade, but the problem with that is aluminum tends to like to just kind of smear out. It doesn't chip when you're using high-speed tools. Consequently, after making this first cut, it was a little faster than the handsaw, but I started using the handsaw after that, which, it works pretty well. It is aluminum. It's fairly soft to cut. You can get a bit more accurate results with a handsaw. So once it started to take shape, it became clear that this was actually going to be a viable project. And one thing I found was that for the alignment of these screws, is you're doing this by hand largely with simple tools for alignment, and so to facilitate alignment, you may end up having to make some oval holes here. So you drill it through and then you ream it out with a drill bit. And my suggestion here is that you go with the alignment with this bottom support bracket. You line the ovals in line here so they go this way. You don't overdo it, but you're just going to have to play around and see how much play that you need. And then with the angle brackets, you you make the oval go in the opposite direction. So the oval on these angle brackets would be going in this direction and in this direction. So your alignment ovals therefore have play in every direction, but retaining the same hole aperture, so that it's a good solid mount. If you're not accustomed to reaming out holes in aluminum with a drill bit, then I suggest you make one attempt first on some scrap metal. And notice how the pull on the bit will not go in the direction you want. So you are going to have to pull at a different angle from the intended direction of the oval. So that's all well and good. You'll figure that out. So anyhow, I think it's just a better bet than iron, but you can use iron if you want. It's going to take longer. It's going to be harder. You're probably going to have to take a chainsaw file and make your oval enlargements with that. It's just going to take more time. But a good thick cast aluminum or forged aluminum, whatever it is. Now to make these holes in the brackets, that is a little trickier. First you mount them on there, screw these on tight enough, and loose mount these in there, and then you take a smaller drill bit that's almost the size of your hole, and you go through and you score it. So you make that pilot bit. It doesn't have to be a small pilot. You can go with I don't know what it was, 3/8, 3/16 or something. So you do a pilot, not too big and not too small, and then you fit it back in there, and you put it carefully in the vise in this direction. So gently here. You don't want to crack it. You're just putting some tension on it. That's all. And so you got the vise here, and you're going through here. These boots would be off, and so you just carefully go. It's a tight fit once you get the right size drill bit in there, and so you carefully go through and holding it steady and with the vise on it. So you give it a little back pressure here, and your drill goes in here, and you drill those out, your secondary bit, so that you get your proper fitment at the same size here, so you won't have any play in there. That's the object with that. Now, because the clearance here is a concern, these are going to be your negative mounts when you eventually put your electrodes in here. So it really doesn't matter, because this all ends up being grounded. These are primary leads. These are just 12 volts. You've got an air gap in there. If it was a high voltage situation, you'd have to be more concerned. Now you can see that there's a slight gap here in between. You're going to want that gap to go away, because you're not going to want flex on these joints. Okay, so that's why you have the oval arrangement here inset, so that as your final placement, you're going to want to loosen these up and clamp these together. Once you get these on, you loosen those up, clamp your coils so that they're touching, and tighten those back up, and that'll give you your maximum clearance for your fuel tank. I think it's a good concept in progress, and there's a few different brands of these. I got the I can't really support one brand or the other, but there's a few brands. I think 3 brands out there of this type of coil that you can choose from. I don't know if there's um, any substantial difference, but you know, it's up to you. If you want to pay more money, go with the better coils. Alright, so I got to start this camera at the proper focal distance in order for it to maintain focus. Um, I have the coils mounted now. I did a dual assembly. You can see the connection there. So that flat part um, goes up against the base of this, the other flat edge of this on that side. So this comes out even to the end here. The metal stock I was using was a little too short, so I only had enough room to go. And just, you can see the shiny edge right there. The outer bolt is there, so I bolted to the inner bolt. It made it a little bit inconvenient for doing the brackets here, but nevertheless, I was able to do it. So that's the way it was hooked up originally. That's the way I hooked it up. You know, whatever the ins and outs are. The schematics are a little difficult to read, the original setup. So anyhow, it ran. I put it back the way it was. We have a totally solid rig here, 4-point connection. That does not move. There's no motion here whatsoever. The other thing is that given that I'm running the coil a little bit hotter than what it was, a little faster, a little hotter coil, I went from 4 ohms per coil to 3 ohms per coil. And since it's a little hotter, having this bracket arrangement that goes onto the base of the 2 coils, as you saw in the previous section of the video, that acts as a radiator. In fact, all of it acts as a radiator. These actually, these are fence post bases, base plates off a fence post, which I cut and bent, and it took a while, so it's not so easy. But you know, it all came together. Just get the right angle. I had to get a little bit of an extra bend right there on those, but these were just straight angles. And I used a 3/8 inch extension bar, ratchet extension bar. I just clamped this in so that you'd get a square down into the vise, and then you start tapping it over, and then you lift that up out of the vise a little bit, and then put your bar up against it and start tapping it around the bar, and you just work it until you get a decent, you know, kind of a round edge on that. So that, you know, it's soft iron and it's ductile, but you don't want to go too sharp of an angle. I put washers, flat washers underneath the aluminum here, because aluminum is a bit soft, so when you tighten it down, that way you get iron to iron and all the way around. This is looking good, and you got to watch your sides here when you go to drill a hole. You can't put them side by side, and you know, they're label them, you know, left front, left rear, right rear, because it's all custom. And of course there's actually there is a manufactured bracket which is all one piece. Maybe you'd have better luck with that, using 2 of those. It costs you $25 plus tax roughly, and then maybe if you put a zip strip around the center to keep them from vibrating, you know, that'd be quicker. But this is actually a better arrangement. It's rock solid, and it's a heat sink. So overall, you know, it's a good arrangement. And the coils are actually just about touching in the center. They're maybe even touching. So they're packed in there, you know, just as good as can be to get your tank down and around it. So you know, that's what you got to have. So that's a good rig, and I'm happy to do it. I was happy to get it done, and if you can get a little bit longer angle stock, you'll have an easier time of it on this end. That's the only thing I can tell you that really could be an improvement. Getting the bolts for this, I could only find these in a hex head inset, and so in order to tighten those, I had to use the Allen wrench with a ball on the end of it. And let me show you here. These here, I got a couple different sets, but so you know, it has a ball on it, so you can get an off angle kind of thing. Because you know the bolt is in the way right here. That's a tough spot, but you really do want to get those tight enough. And I use silicone grease everywhere. So now I'm ready for the next stage, which is to cut the new wires and put the new plugs and plug caps on, and all pretty basic from there. So yeah, this is a good rig. I'm glad I bought this, and it's working out just fine. So it was you know, kind of sketchy at first. I wasn't too sure just how well it would work, but you know, I had vibration gouges in my wires that I didn't realize. I had some rodent chew up here, you know, some checks that I didn't realize in there. I mean, it was going. So the positive connections on the coil, the terminal that's inside of the coil itself, it came slightly recessed, so I had to kind of clean it off with a knife a little bit. So to make a good connection, I needed to have a small head bolt that was no bigger than the actual fitting that it's screwed into. So I ended up getting this hex head little bolt, which works okay. And I just put a wishbone connector in there, and then cranked it on, you know, pretty firmly. So that was one point I wanted to make. The 90-degree elbows work out rather nicely. You can see it gives it a nice line here, and also it sets this secondary plug line. It goes in a nice way that way. So I wasn't so sure that was going to work out, but it really does work out rather nicely like that. So it looks pretty good at this point. It's back to the original specs as far as that goes, because let's see, there's two different types: plug, ES on top, and HS on bottom. And these are non-resistor, there's no R. So that's the top one. The top one has a longer shaft on it, more threads. So in putting it back to putting it back to original, or nearly so, I used a low resistance plug cap. So instead of a 5K, it's a 1K resistance suppression cap. So that is what the original called for, and that is what the replacement plug cap is still sold as, with a metal heat shield on it. This is a hard plastic, so we'll see how well these rubber grommets on there hold up. The plugs themselves are non-resistance plugs, so there's no R in them, no R in the letters. So that's about it. I used a solid core 8mm wire, tinned copper, and it took me just an afternoon or so to get it all together, but no, that's actually not true. It was a process. You can't buy, at least I couldn't find a set of wires for this bike. You could find just a set for the top, the stock plug wires. So if you're going to have to make your own plug wires, you might as well make all of them. That's what I figured. So it's looking pretty good now. It's about ready to fire. Okay, so I started out with 9 feet of 8mm high temperature wire core, and I have just about 2 feet left over, so it's just slightly short of 2 feet by about 1/4 of an inch. I could have done it with 7 feet would have done this, and this is a pretty good layout the way it sits now. Yeah, it looks pretty good. I might have to put some sort of tie on this. I'll keep an eye on that for abrasion, but I think that's pretty good overall. So you could do it with 7. I'm sure of it. I mean, I have enough slack and everything. You could easily do it in 7, as long as you're careful not to waste anything.